Okay, pre-calc, here is lesson 5-7, inverse trig functions. Yesterday we did some work with inverse functions, and so now we're going to apply that to our trig functions. Please first note that this -1 here does not mean an exponent. It is not an exponent, so just keep that in mind. Also remember that we have inverse trig functions, which we're going to look at today. And we also have reciprocal functions. Okay, and so those are different. You know, reciprocal functions are cosecant, secant, and cotangent. Whereas inverse trig is sine, -1 cosine to the -1 and tangent to the -1, and technically you also can have cosecant to the -1, secant to the -1, and cotangent to the -1. So these are your reciprocals, and the rest are your inverse trig. And also notice that we are calling them functions, so we have to put some limitations on in order to make them functions. Okay, so let's just look at inverse sine first. The way we talk about our inverse sine is sine to the -1. That's the one on your calculator. Another way to say the inverse sine is we use arc sine, and you're going to see that a lot. So the arc sine of x is the exact same thing as the sine to the -1 of x. All right. So in order to make these functions, we have to limit our domain and range. And so you already see the graph here of inverse sine. And so on this graph, notice the up and down, the y-axis we'll call it, is our radian degrees. And the x is just regular numbers, and that is because we're doing the inverse. So our domain goes from -1 to +1, inclusive, -1 to +1. And our range goes from -π/2 to +π/2, inclusive. Now, if we would continue this graph, because it's the inverse sine, remember, it would just go like this. It would come down and it would keep going, you know. And it's that periodic sine graph. And so that would now not be a function. That would not pass the vertical line test. And that is why we limit our domain. And we also limit our range. Okay, let's see. Please notice on this, because of this range, that over here in quadrant 1, we are positive. And over here, well, I'm going to get to that later, because that'll make more sense later. Okay, inverse cosine. So now we're doing our inverse cosine graph. Another way to say that is arc cosine. The domain here is from -1 to 1. The range here is from 0 to π. And again, it would just keep repeating, and so that is why we have to limit our domain and our range, because this would not be a function. Tangent, the inverse tangent. Remember, if you were thinking of a tangent graph, it repeats. And so this right here, what we would have is an asymptote here, right? And then we would have another graph like this, and we'd have an asymptote here, and we'd have another graph like that. And so again, that's not a function. So we have to limit our range so we have a function. Now the domain this time doesn't need to be limited. These go on forever. So we have -∞ to +∞ for our domain. But for our range, we don't want to go any higher than π/2. And I guess technically we would start down here at -π/2 to positive pi over 2, and those are parentheses. We are not including those because those are asymptotes, and so we cannot have the brackets like we did for cosine and sine. So we limit our range on our inverse tan. We limit our domain and range on the others, although limiting the domain is a little bit redundant because, you know, the domain's never going to go beyond that. So the most important thing on all of these is that we are limiting our range. Okay, so using that information, hold on a moment. Okay, so note that based on that limitation of the ranges in these functions, for the graphs of the inverse functions and the unit circle, we know that the angle will be located in. So what I'm trying to say is if you are trying to find the inverse sine of a positive number, your answer is going to be in quadrant 1. And if you are going to find the inverse cosine of a number, your answer will be in quadrant 1. And the inverse tan of a number, it will be in quadrant 1. And that is because up here, all of these, look at, if I am finding the value of a number, of a positive number, you are over here in quadrant 1. Okay? Now this is a little bit misconceiving because these are not the unit circle. So you need to visualize the unit circle really more on this. But you are going to be, anytime you're finding a positive number, you're going to be over here. This would be positive for all of these. And then for the inverse sine of a negative number, when you're doing sine, you're in quadrant 4. Which means you will do a negative angle measure because you're going negative. And if you're doing an inverse cosine of a negative number, you are going to be in quadrant 2, which means any angle measure will be over here. And so you'll have to add that first quadrant portion to it. And then inverse tangent will also be in quadrant 4. And this is just something you kind of need to memorize. And we're going to be using it. So one way they say you can memorize that is for cosine, you envision the sun going, or I don't know what they say, something about the sun going down or something. And for sine and tangent, you envision it going this way. Because those are quadrants 1 and 4, and cosine is quadrants 1 and 2. So I don't know if that's helping because it's not really the sun, but I don't remember what the details of that little memory trick were. You just need to know it. Okay, this means that for sine and tangent, you will have answers of negative acute angle measures. For sine and tan, I should say for inverse sine and inverse tan, you will have answers of negative acute angle measures, but for inverse cosine, you will have angle measures from 0 to pi or 0 to 180 degrees. So let's go through these. Example 1, find the exact value in radians. Now we have done inverse trig before, and so please remember that what we're trying to do in these is we're trying to say what angle measure makes this true. Okay, so you're going to say, okay, the cosine -1 of 0. Basically, you're saying the cosine of theta equals 0. Also remember, for the unit circle, we are looking at x is the cosine, y is the sine. All right, and so this is now a quadrant angle. When is the cosine of theta 0? Well, we know the cosine of theta is 0 at this point, which is at 0, 1. And we know it's down here at 0, -1. But remember right here, we limited our inverse cosine from 0 to pi. So therefore, we have to go with theta equals pi over 2. Next one, the sine. Well, that would give me here the sign is 0, which is 1, 0. And here, the sign is 0, which is 1, 0. But we limited our sign to be in quadrant 1 or 4. And so we have to go here. So this would have to be 0. Okay? And remember, what we're really asking here is the sign of what number is 0, or what angle is 0. All right, here, the sign of what angle is negative 1 over radical 2. And so this is a negative, so therefore we know we're going to be in quadrant 4. And so we're going to write our, we can draw our angle if that helps you. There's your theta right there. Since we're dealing with 1 over 2, we are dealing, or 1 over radical 2, we're dealing with a 45, 45, 90 angle, correct? And so we would have to have it be a 45 is our angle measure, so 45 degrees, which is pi over 4. Next one, arctan of 1, and this is saying the tangent of what angle is 1. So again, you know you're dealing with a 45-degree angle because that is the 1. First of all, it's positive, so it's going to be there, 1, 1. There's theta. To get 1, you have to have it at 45 degrees, which is pi over 4. I think it said to do them in meridians, yeah. Okay, next one. So this is saying the cosine of what angle is 1/2. And so we're positive 1/2, and so we're in quadrant 1. There it is, right there. This is 2. This is your pi over 6. So this is your 30. There's 1. This is radical 3. And so 1 over 2 right there, to be cosine, we would say that is a 60-degree angle, which is pi over 3. And the reason I know this 1 is here is because it's cosine 1 over, this has to be the adjacent, right? And therefore that has to be the 30 degree, and this would be the 60. Next one, you're saying the tangent of what angle is negative radical 3. So we're in tangent and negative, and it's negative, so we have to be in quadrant 4. There's your angle. That's a really bad picture because I got to fix that. Hold on. All right. We're looking at this more. And this is your angle. And if we want it to be a radical 3, here's your 1. Sorry about that. That's not your 1. Here's your 1. Here's your radical 3. Here's your 2. So if tangent's going to be opposite over adjacent, it has to be radical 3 here, 1 there, which means this is your small angle, pi over 6, and this is your big angle, pi over 3. But since we are in quadrant 4 down there, it's a negative pi over 3. Arc sine. All right, so there, this one is saying the sine of what angle is negative radical 3 over 2. So we know again, sine, we're going to be down here. The sine is opposite over hypotenuse, so there's my 1 this time. And 1 is, of course, opposite the smallest angle, so this has to be pi over 3, and it's negative because we're in quadrant 4. Here we are at the cosine, so we're saying the cosine of what angle is going to be a negative radical 3 over 2. And since we are cosine, we are over here in quadrant 2. There's my angle. Cosine is adjacent over hypotenuse, so this is radical 3, and here's my 1. And so therefore this would have to be pi over 3. And so for the cosines though, you have to be careful because what we're talking about with cosine, the cosines of negative numbers. Be very careful here. We're technically talking about this angle. The pi over 3 is the reference angle. The reference angle is pi over 3. And so what would the yellow angle here be? Well, that would be, this is 6 pi. No, I'm sorry, I don't know why I'm doing 6 pi. 3 pi over 3 minus pi over 3 is, oh man, this is not pi over 3. There's my problem. This is, if this is 1, then this is pi over 6. Let me just clean this up. Sorry about, I know only a couple of you are watching this video, but that was bad. Okay, here we go. Start over. If this is pi, here's your 1. This has to be pi over 6. Because it's opposite the 1, so it's the smallest angle. So this, the reference angle is pi over 6. The question is, though, what is this angle? Not what is the reference angle, what is this angle? And that angle would have to be pi, right here is pi over 2. So that would be 3 pi over 6 plus another 2 pi over 6 to get to the reference angle, and so our total is 5 pi over 6. Another way you could do that is this is 6 pi over 6 minus pi over 6. That gives me the 5 pi over 6. So for when you're doing the inverse cosine of a negative angle, be very careful. I'm interested in this angle, not in the reference angle. Okay? Example 2. Use a calculator to find an approximate value, express your answer in degrees. So make sure you are in degrees. If you forget how to do that, you hit the mode button and you make sure you're in degrees. Your answer, I'm just going to let you do that. I don't think you need to see me do that on a calculator. This is negative 71.565. This is 63.896. Then doing example 3. This time we're in radians, and so this gives you 0.120, and this one gives you 0.197. So this is just calculator work. Hopefully that's going to be okay with you. All right, compositions with inverse functions. So this is the tricky part. You're going to work from the inside out, and you need to remember your domain and range restrictions. So what we're going to do here is we are going to say, we're going to call all of this theta. Okay? And so what we're essentially saying is, what is the sine of theta? But the first thing we got to answer is right here. So the tangent of what angle is negative radical 3? And so you stick that on your on your graph, and we are simply answering this question right now. The tangent of what angle is negative 3? So we have to be in quadrant 2. There's my theta. Since its tangent is radical 3, that means the opposite is radical 3, the adjacent is 1, and there's my hypotenuse. And so we would have to then say this angle is your pi over 6, and this angle is your pi over 3. So this is negative pi over 3. So then what we're trying to find is the sine, bring down your sine, of negative pi over 3. And the sine of negative pi over 3 is opposite over hypotenuse is negative radical 3 over 2. And there's the answer to the problem. Let's do another one here. This is saying what is the inverse cosine of a number. Now this here is not an angle, this is a number. We need to find that number. What's the cosine of 5 pi over 3? So we can do that. We're going to go here. 5 pi over 3, this is 6 pi over 3. No, it's not. This is 6 pi over 3. This is 3 pi over 3. So we're going all the way to here. And then we need to go to 5 pi. Oh my. So 5 pi over 3. 5 pi over 3 is, oh my goodness, 5 pi over, why? Tell me why. Why are you doing that? Let's just press that again, see if it works. 5 pi, oh my goodness. Okay, I'm going to just say that 5 pi over 3 is 1/2. And so, come on, hold on, let me pause you. Okay, I just had to close it all out and do it again. So anyhow, I've drawn in our angle 5 pi over 3. It takes us right to here, our theta reference. Is going to be pi over 3. And so that's our 60, there's our 31, radical 3, 2. So 5 pi over 3, the cosine of 5 pi over 3 is adjacent over hypotenuse. So this equals 1/2. And so then the question is cosine to the -1 of 1/2, which means the cosine of what angle is 1/2. And by the way, no, that's positive. Okay, so the cosine of what angle is 1/2? That would be a pi over 3, and it would be positive. And there's your answer there. So just remember, when you work on these equations, composition, remember compositions are just when you do a couple different things rather than one step, okay? And so you need to work from the inside out. Remember your domain and range restrictions. And here we go, one more. These, what we're going to do here is we're going to make a right triangle with the hypotenuse being 1. So I'll show you what this means. So this is find the algebraic expression equivalent to the given expression. Notice the difference between example 5 and example 4. Example 5, there was no variable in 5. I'm sorry, in 4. No variable there. There was a value. Value, value. So you can give me a value as an answer. These have a variable. And so to solve this, we're going to do it a little differently. We're going to still say, okay, this is my angle right there. And so what this says is the sine of the cosine of what angle equals x. And so we want the sine of that angle. And so I'm just going to work with this a little bit. The cosine of what angle equals x over 1. So I'm going to draw a right triangle here. And I'm going to call this my angle theta. So the cosine of this angle, the adjacent is x, the hypotenuse is 1, and I'm just going to call the opposite y. And now, what is the relationship here? We're looking at a right triangle. What is the relationship there? Well, using Pythagoras, I can say 1 squared equals x squared plus y squared. And now I want to solve that equation for y. So that means 1 minus x squared equals y squared. And so y is going to equal the square root of 1 minus x squared. And so therefore, I can say that this value right here is this side length. Y equals the square root of 1 minus x squared. And so all of this original problem said, what is the sine of theta? Well, this is theta. And so I have the triangle I'm going to use to solve that. So I am going to say, well, then the sine of all of this, which I'm going to call theta right there, is going to be, sine is always opposite over hypotenuse. So y, which we found to be 1 minus x squared over 1, which is simply 1 minus x squared. And there's your answer. So you are going to draw a right triangle with these based on the information you're given from the inside, and then you are going to give the final answer based on that right triangle. So let's do another one. We're going to call this theta. That is theta. And that says the sine of what angle is 2x. So we're finding the cotangent of that. Okay, so I'm going to draw a right triangle. Here's my theta. The sine is 2x. I'm going to put 2x over 1. Now sine is opposite, so this is my 2x over my hypotenuse is 1. Put a 1 there, and I'm going to call this y. What is the relationship there? 1 squared equals y squared plus 2x squared, which is 4x squared. Got to square the 2. Solve that for y. So 1 minus 4x squared equals y squared. And then y is going to equal the square root of 1 minus 4x squared. And that is my value for y, which is this side length. And this, theta, represents that angle. So what is cotangent? Well, tangent is opposite over adjacent. So therefore, cotangent is adjacent over opposite. So my adjacent side here is the square root of 1 minus 4x squared, and my opposite side is 2x. And that is your answer. So those are a little tricky, but anyhow, that's the end of the lesson.